All right, so Marta is repurposing a sandbox as a garden. The sandbox is a rectangular prism that's 4 feet by 4 feet by 10 inches. She is buying soil in bags that are rectangular prisms that are 10 inches by 18 inches by 5 inches. Estimate the number of bags she should buy. First off, the pictures aren't drawn this time. It says the sandbox is a rectangular prism. The soil bags are also rectangular prisms. So we're dealing with rectangular prisms. And if the three-dimensional picture isn't drawn for you, I'd recommend that you draw it. Okay? Drawing a three-dimensional rectangular prism goes like this. Okay? Before I draw it, though, did anybody notice anything about the units there that might cause us some issues? We got feet and inches for the sandbox, right? So the sandbox is 4 feet by 4 feet by 10 inches. So the units aren't the same. We're trying to figure out how many bags of soil we need, and the bags of soil are 10 inches by 18 inches by 5 inches. Everything's in inches. So it probably makes sense to get everything into inches. So would everybody agree that 1 foot is equal to 12 inches?
Yes.
So if I have 4 feet, I'm going to multiply by a fraction including these two pieces in such a way that feet cancel and inches are left over. So I want feet to cancel. So feet is currently in the top, I'll put a feet in the bottom. And 1 foot is equal to 12 inches. So this fraction here is made up of this fact. The unit that I want to get rid of must be put in the denominator of the fact I'm using. So they cancel, and 4 times 12 is 48, so 48 inches. That's called dimensional analysis. It's just something you have to be able to do in higher level math. So 48 inches is the same as 4 feet. Sometimes people say if you go from feet to inches, you multiply by 12. I prefer to have a technique to do it, so you can go whichever direction you need to go whenever you need to go. So a rectangular prism has a length, a width, and a height. It doesn't matter what's what. It doesn't matter what the length, the width, and the height are. For me, though, if it's a sandbox, I like to see what the sandbox actually looks like in real life. Usually sandboxes are wide and not very deep, right? So I'm thinking 10's the height, and the other two are the length and width. So to draw a three-dimensional rectangular prism, you start by drawing the front of it. So draw a rectangle. This rectangle is 10 inches by 48 inches. All right. So draw the front edge first. Then if you just draw slanted lines off of each corner about the same length. Okay. This is not art class, it's not going to be perfect. Kind of draw them the same length there. And you go straight across and straight down. It should resemble a three-dimensional rectangular prism. All right. The width, so length, height, width would be 48 inches as well. So we want to see the 3 dimensions of our rectangular prism there. Okay. If we visualize this so we see the back side of it, if we just put some dashed lines in to represent what we couldn't see maybe. Like so. The base, what we've been using as the base has been this rectangle in the bottom for rectangular prism, right? So the bottom rectangle in this picture is a 48 inch by 48 inch rectangle. So after I've drawn my three-dimensional picture, I want to draw my base 48 inches by 48 inches. And I want to find the area of that base and the height of the solid. So how do I find the area of a rectangle? Multiply what? Length and width, all right? In this case, 48 times 48, 2,304 square inches. That's what it was this morning when I did it, so I'm assuming it's still that. Feel free to use a calculator if necessary. All right? So the area of the base comes from the two-dimensional base. The height of the solid comes from the three-dimensional solid. So the height is how far apart the bases are. So a rectangular solid has a bottom and a top that match. They're the same rectangle. They're separated by a distance of 10 inches. So the height of this thing is 10 inches. So the volume of the sandbox is going to be area of the base times the height 2,304 times 10, which is equal to 23,040 cubic inches. Okay. We want to fill this sandbox with soil. Okay, she's repurposing the sandbox into a garden. She wants to fill the garden with soil so she can plant all her vegetables, make her salsa and dips and stuff for the summer, right? So, the way this works is the capacity of the sandbox is that amount of cubic inches. The bags of soil have some volume, that's the capacity of soil in a bag, right? So we want to figure out the capacity or the amount of soil in each bag. So if I'm looking at the soil bag, the soil bag dimensions are 10 inches by 18 inches by 5 inches. And again, that's a length and a width and a height. It doesn't matter what's what. You can call any dimension anything in a rectangular prism, doesn't matter. So for the sake of having dimensions, I'm going to say that it's 5 inches up and it's 18 across for the front. 5 inches across, 18 inches, there we go, 5 inches up, 18 inches across. So pick two of the dimensions to make the front rectangle. The dimension going in depth, going back into the board, again, if I just draw slanted lines to represent that, like so, put some dotted lines in to represent what we can't see, finish out the rectangle. So this depth here is going to be the other dimension we haven't used yet, which is 10 inches. So there's my bag of soil, drawn three-dimensionally, so it looks like that. The only reason I'd ever draw a three-dimensional picture on my paper is if it's not included in the problem. If the three-dimensional picture is somewhere that I can look at, I don't need to draw the three-dimensional. So if the sandbox is already drawn for me, I would have just done this work here, where I drew the base and everything else. If I haven't got a picture, I want to see the picture, so I'm going to draw the three-dimensional picture. So if I'm going to make the base the bottom again, the base is 18 inches by 10 inches. That's my base here. Right? The area of the base is equal to 18 times 10. Again, it's a rectangle again, so it's just length times width. So the area of the base is going to be 180 square inches. The height of the bag, again, if the base is this 10 by 18 rectangle, the other base is 5 inches above it, so the height is 5 inches. So the volume is equal to the area of the base, 180 square inches, times the height of 5 inches, which is equal to 900 inches cubed. And feel free to use a calculator to calculate things. That's what 180 times 5 equals. So we found the volume of one bag of soil. We found the volume of the sandbox. We want to fill up the sandbox with bags of soil. Okay? If I was creating a multiplication problem to represent what's happening here, I'd multiply 900, the amount of soil in one bag, times what to get how much we need to fill. What would I multiply the volume of one bag of soil times? I want to fill a sandbox. I got to multiply the volume of one bag of soil times something to get how much I need. You don't know what the something is. What is the something we're looking for?
How many bags?
How many bags? We don't know how many bags of soil we need, but that's what we would do, right? We take how much one bag is capacity, right? 900 cubic inches capacity of one bag, multiply by exactly how many bags we need to create the capacity we want, right? Which is this 23,040. So if I'm looking at this as an algebra problem at this point, the volume of one bag of soil, 900 cubic inches, times the number of bags I need to buy, which I don't know, is going to equal the capacity I need to fill, which is 23,040 cubic inches. Capacity of one bag times I don't know how many bags should equal how much I want, 23,040. How do I solve that? Divide by 900, right? So divide both sides by 900. And I don't remember what that equals from earlier, so I'm gonna type that in again. 23,040 divided by 900 is equal to 25.6. Now, if you go to the store to buy some soil, and they come in bags, can you buy 0.6 bag of soil? No, you can't buy, so you have to buy an extra bag. So 26 bags is what she'll need to buy in order to do this. 26 bags.
What do you just wing it with 25?
We'll go 26. We want to fill it exactly to the top. We want to have a little extra too in case
Just
it
move
settles.
around.
Sometimes things settle a little bit, so you have to have a little extra dirt maybe. But yeah, if you go to the store and say, I'd like 0.6 of a bag of soil, they're going to say, I don't think so. They won't do that. So anyway.
Empty one.